In this video, I have a quadratic equation and I'm going to solve it using the box method. Now there's a easier, quicker way to solve this too, but I'm just going to run through the box method just to show you how it can be used with solving most quadratic equations, the ones that could be solved using factoring. So anyways, let's start off by creating my box over here on the right side. And the first term that I want to plug up here in the top left hand corner is my x squared term, and that is referring to my ax squared term in the standard form of a quadratic equation, which is this right here. So there is my ax squared term, and then in the bottom right hand corner I plug in my c term, or my constant, which is -49, and there's my c term right there. My next step would be to multiply these two terms together. So I'm going to do that down here. It's going to give me a -49x squared. And now I have to think of two terms that multiply together to give me -49x squared. And they also have to add up to be my middle term here, which would be bx, except there's no middle term that is my bx. It's just 0. Because if you look at here, bx is in the middle. And really, if I rewrite this, my bx term again is equal to 0. Because if my b is equal to 0, well, 0 times anything for x is going to be 0, so it goes away, and I'm just left with x squared minus 49 equals 0. Okay, so back to my problem here. I need two factors of -49x squared that add up to be basically 0. Now I'm going to set up a factoring table over here on the right side, and I'm going to come up with a couple pairs of factor here for my -49x squared. One is going to be my x times 49x. One of these has to be a negative number, so let's just make this -49x a negative. And then two more factors of -49x squared would be a 7x times itself, a 7x, but one of them has to be negative. Now remember, the pair of factors have to add together to give me 0. So if I add these two terms together, I'm going to get a -48x, which obviously is not 0. But if I add together 7x and a -7x, that's going to give me my 0x's, which I wanted. So here's the pair of factors that I'm going to use. I plug that into my two remaining boxes here. Now I want to factor out the greatest common factor from both these two terms, so that's going to be an x. And I factor out the GCF between these two terms, which is going to be a 7. And I always take the sign of the term closest to the closest to the number that I put out here. So that's going to be a negative. I do the GCF between these two terms, which is going to be an x. And then the greatest common factor between these two terms, 7x and -49, is just an x. And these are going to be my factors. So I'm going to write my factors of x minus 7 and x plus 7, which equals 0. Now I can set both equal to 0 and solve. So I'm going to add 7 to this side, add 7 to the right side. So I'm left with x equaling 7. And then I want to take away 7 here, so I subtract it, which goes away. I subtract it from the right side as well. And I'm left with x equaling -7, which is my other answer. Now, just as a tip, whenever you see a perfect square here, which is x squared, and then a perfect square here, which is 49, and you have a subtraction sign right in the middle, you could just take the square root of x squared, which is x, and that's going to be your first term in the binomial. Then you could take the square root of your second term, which is going to be 7. The square root of 49 is 7. That's going to be your other term. Your other number, and then one's going to be subtraction, one's going to be addition, and you could do that every time. It's called the difference of two squares. So you could avoid doing the Bax method if you wanted to.